perfect problem 2 for Math 243. We're asked to do a lot of stuff and given kind of a lot of data. So I don't know, you might want to do this on a separate piece of paper, or maybe you did it using a computer or some statistical software. Who knows? But I'll try to sketch out a solution, although yours will probably look a lot better than mine. So the first step is to create a scatter plot for the data below. Okay, what is the data? We're given a list of the total payroll, so how much baseball teams spent in salary each year, and how many wins they got that year. So what we have here is 2 sets of data, and it seems like this data causes this data. The more money you spend, the more wins maybe you'd expect to get. So I would say that over here we have our explanatory variable, and over here maybe I'll add a little x for explanatory and y for response over here. So create a scatter plot. All right, I can do that. Always throw your explanatory variable over here. So we'll say payroll, and you put your response maybe in millions. And your response over here, these are how many wins you got. And let's see, wins, they go all the way up to 100. And payroll appears to go from 50 up to 200. Okay, so you have the choice. You can start your axis, you can label your axis however you want. Maybe the easiest way is just to start it at 0. Although if you want to get a little bit clever, you could figure out what your lowest payroll is. I think it's my beloved Oakland A's. They only spent 50 million, so you could start at 50 here and go up to 200. But I'm just going to start at 0. We'll call this 50, call this 100, call this 150, and call this 200. And then over here, wins. Let's see, I don't know who the worst team in baseball was that year. The Twins winning 63 was pretty bad. Not looking too carefully. Maybe there's one a little bit worse than that. 56, the Astros, that's really bad. But anyways, you could start with 56 and go up to 100 or whatever. The most were the Phillies. They won 102. But it might be easier to just start at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So you can make your scale differently if you want, but I think this will end up being the easiest. And then what you do is you go through and you plot all these points. So the A's paid $55 million and they won 74 games. So 55 is here, 50, 60, 74 is something like there. And you go and repeat that for all this data. I'll go ahead and do that. I'll pause this so you don't have to watch me do it. Here's all our data. Here's our scatter plot right here. It kind of looks like we have a positive correlation. It seems like if you spend more money, you win more games. But it's not a really strong linear correlation. Let's see, we're asked to label a couple of these points. The A's were 55 and 74. So 50, 60, 70, that was probably this guy right here. So I'll label this one as the A's because I'm an A's fan. This one out here is kind of interesting because they spent so much money. This is the Yankees, of course. They spend a ton. Who else? This one's kind of interesting in that they spent a lot of money, but they really didn't win that much. Let's see, someone spent 150 million, but only won 86 games. This is the Los Angeles Angels. So I don't know, that's kind of interesting. And this guy right here is kind of interesting too. You didn't spend that much money, but he won, what, almost 100 games, 95 games, something like that. That's probably the Arizona Diamondbacks. Diamondbacks. So I don't know, there's a few points that I found especially interesting. So we calculated a least squared regression. So we created a scatter plot and we labeled a few points. So now what we want to do is calculate a least squared regression line and interpret it. So the way you calculate a least squared regression line, maybe I'll come down here to calculate least squared regression line. You use your calculator and you go stat, stat, and then over to calc. And then down to lin reg. and then you reference your lists. So maybe L1, L2. So if we put this data in L1 and this data in L2 and we go through this, we'll get a least squared regression line out of our calculator. Okay, so if you get this into your calculator, what will come out is it tells you that A equals 0.188 approximately, and B is equal to 62.5 approximately. So what that says is that your least squared regression line, y prime, or y hat, is equal to ax plus b, so 0.188x plus 62.5. So what we have right here is a least squared regression line, which I can plot. I should probably change colors. If I want to plot this least squared regression line up here, my y-intercept is 62.5, so 50, 60, 62.5, and my slope is 0.188. So when I go over 100, I go up 18. So let's see, up 18 would be about here, over 100, right around there, and then up 18 more, over 100 more, somewhere over there. So my least squared regression line, I'll try my best to make it a line. Looks something like that. All right, so what have I done so far? I calculated the least squared regression line. I was supposed to interpret the slope and the intercept and then plot the line on the scatter plot. Okay, so what this means is that it doesn't really make sense. It's saying if you spend $0 on payroll, you still win 62.5 games. And what this is saying is for every additional million, because these are in millions, $1 million you spend, you win 0.188 more games. All right. Another thing that was kicked out of our calculator when we did this linear regression was that r squared is equal to 0.37. So what that tells us, so 37% of variance in wins is explained by payroll. So what I'm saying is there's a lot of factors that determine how many games you win, but 37% of how much these wins vary, if you just look at this column right here, sure there's a lot of variance, 37% of that variance is determined by the payroll. So comment on how well your regression line fits. So I don't know, 37% isn't huge, so maybe I'd add here. So not a great fit. Not a great fit. Sure, good enough. All right, finally, or I guess not finally, still a couple steps. Might have gone a little overboard with this problem. Estimate my beard's worth $100 million if I shaved it, blah, blah, blah. Okay, so what this is saying is what is my predicted value if x equals 100? Well, I have this equation down here. So what I can do is say 0.188 times 100 plus 62.5. So if you multiply this by 100, you get 18.8, and if you add that to 62.5, you get 81.3. So what it's saying is if you spent $100 million on a team, you'd expect 81.3 wins. The record for most wins is 116. So let's see what color to go to now, maybe orange. Is 116, how much money would you have to spend? So it's kind of using this equation again, but now it's telling you how many wins. So it's telling you 116. And it's saying that's equal to 0.188 times what? Plus 62.5. How much would you have to spend to win 116 games? And you can solve this. The way you solve this is subtract 62.5 from both sides of the equation. So you do 116 minus 62.5, and you get 53.5 is equal to 0.118x. So now if you divide by 0.188, I think I said 118, but it's 188. I better fix this. Might have just made it worse. Maybe it's worth rewriting. 0.188x. So divide both sides by 0.188, and what you'll get is that x is equal to 284.6. So you'd have to spend $284.6 million if you wanted to win 116 games. I don't really have room to write all this stuff, but maybe that's good enough. Maybe this question right here is answered down here, and this question right here is answered over here, and everything else is somewhere on this big mess. So again, maybe a little bit ambitious, but that's the end of this ambitious perfect problem.